Hello everyone, my name is Bosch and I am student of Electronics and Communication Engineering. Today I am excited to kick off our video presentation, but before we delve into details of our internship journey, I would like to take a moment to express our sincere gratitude. First and foremost, on behalf of my team, Vinay and Sai, I want to extend our heartfelt thanks to Emertxe for giving us this incredible opportunity. It's been an enlightenment to transformative experience and we are thrilled to share our internship journey with you. Emertxe has been a guiding light throughout our internship, providing us with invaluable knowledge, mentorship and a platform to explore and grow in the field of embedded systems and electronics, and we are truly grateful for the trust that they have placed in us. So, without further ado, let's dive into our internship adventure at Emetrix, where we had the chance to learn, experiment, and apply our skills in real world scenarios. Join us as we walk through our experiments, projects, and the invaluable lessons we have gained through this journey. Thank you once again to Emetrix and to all of you joining us on this ride. Let's get started. In this slide, we will discuss about the contents for the project. For project requirements, the project is about micro oven, and we will discuss about the requirements to do the microwave and embedded systems project, and we will do to introduction to the micro oven, what the micro how do is and modes of micro oven and embedded system. An embedded system is a combination of computer hardware and software designed for a specific function. Embedded system may also functions a larger systems. The systems can be programmable or have a fixed functionality. Industrial machines, consumer electronics, agriculture and processing industrial devices, etc. are used by are possible by embedded systems. Microprocessor and microcontroller. A microprocessor is a processor where the memory and input-output components are connected externally. A microcontroller is a controlling device where the memory and input-output components are present internally. The circuit of a microcontroller is complex when compared to the microprocessor. Project peripherals. In this, we will discuss about the peripheral devices that are connected to the microprocessor, microcontrollers to make the micro oven. Next, we will discuss about the CLCD. LCD is a liquid crystal displays. These are very frequently used for applications for displaying the information in the text or image format. LCD used for displaying the alphanumeric characters on the screen. The LCD consists of 8 data lines and 3 control lines, which is used for interfacing the LCD display with the microprocessor or microcontroller. Next, tactile switch. Tactile switch is one type of switch that is widely used when pressure is applied to the device by the user, which gives the user a predictable click on the haptic bump in the response, indicating current flow. Current flows in turn off when the switch is released. Matrix keyboard. Matrix keyboard is a type of keyboard that, for example, let us consider the 4 into 4 matrix keyboard. In this, there are 4 rows and 4 columns. Then the possible switches is switch keys in the keypad is 16. The pressure key is found by the microprocessor or microcontroller using the resistance. Next, interrupt. Interrupt stops the continuous flow of execution, and the interrupts are very important in embedded systems. The interrupt priority vector gives the priority of the interrupts. Next, ISR. Interrupt service routine is a software routine that the hardware invokes in response to the interrupt. ISR examines an interrupt and determines how to handle it, execute the handling, and returns to a logical interrupt value. Next, timers. They are used to keep a record of time for different events occurred in the embedded system. The timer is a simple binary counter which is configured in a circuit or a system as per the need to count the pulses in the system. Project implementation. How the project is implemented during these embedded systems. In this slide, we will discuss about the topics learned during the internship. They are introduction to embedded C programming, array and pointers, functions and string, preprocessor, storage classes, conditional loops and operations, introduction to embedded systems, microcontrollers, PIC, SIMLab, MPLab, XIDE, XE8 compiler, introduction to various peripherals of PIC 16F877A, multiple tests, and Disha workshop. In this slide, I will discuss about the introduction to microwave. Microwave are convenient means to heat food and are generally safe when used correctly. Microwaves heat food using microwaves, a form of electromagnetic radiation similar to radio waves. The microwave is produces microwaves. Generally, microwaves are not very harm if you use it properly. The radiation of microwaves causes different health issues, but the microwaves used in the microwaves are not very high effective. They are producing heat to our food, and they do not harm to human beings. There are several modes in these micro ovens operated in this particular project. We will focus on the four modes, which are as follows: micro mode, grill mode, convection mode, and start mode. Micro mode: in this process the frequency generated inside of the oven works and generates high frequency waves which cook food from inside out. In this mode, it is used to cook in a traditional way. It generally requires a maximum power of 900 watt. Next, we will discuss grill mode. It is a simply used for grilling. The user can set any time accordingly. It is similar to micro mode, but it is used to more to cook breads, meat, and other items. Third mode is convection mode. It is used for baking. In this mode, the user can set the oven to preheat for 3 minutes for a particular temperature. After preheating is done, the user can set a timer according to the requirement. Fourth, start mode. Start mode is the default setting in any micro oven and is used when you want to heat or cook something without using any specific cooking mode. Simply input the desired time and power level, then press start. It is very simple and it is the default mode in any micro oven. It is customizable. Start mode is highly customizable, allowing you to manually adjust the cooking time and power level based on your specific cooking needs. It's a versatile option for various cooking tasks. The requirements of our project: MPLab XIDE, XC8 compiler, PIC SIMLab. In this, there are 5 components that we are used: PIC 16F877A and 16 into X CLCD, MKB, timers 2, and a tactile switch. What is embedded system? Embedded systems is a computer system, a combination of computer processor, computer memory, and input-output peripheral devices that has a dedicated function within a larger mechanical or electronic systems. Modern embedded systems are often based on microcontrollers, that is, microprocessor with integrated memory and peripheral interfaces. But ordinary microprocessors use external chips for memory and peripheral interface circuits and are also common, especially in complex systems. Type of embedded systems are standalone embedded system, real-time systems, networked, and mobile. I hand out to my friend Purna. He will continue the remaining slides.
Hello guys, my name is Purnamahas. I am studying in SRKR Engineering College, Bhimavaram, in Electronics and Communication Engineering branch. In the part of the embedded system internship in Emertxe company, we have done a project on micro. I would like to tell about the embedded systems. An embedded system is a computer system. It is a combination of the computer processor, computer memory, and input-output peripheral device that has a dedicated function within a large mechanical or electronic system. Modern embedded systems are often based on the microcontroller, that is microprocessor with integrated memory and peripheral interfaces. But ordinary microprocessors using external chips for memory and peripheral interface circuits are also common, especially in more complex systems. There are different types of embedded systems. They are the standalone embedded systems, real-time embedded systems, network embedded systems, and mobile embedded systems. Standalone embedded systems are the one of the type of the embedded system. The name suggests it does not require a host system like a computer or a processor, as it works by itself and displays the data on the connected device or make necessary changes on the device. Input data is taken from the ports as analog or digital signals, and processing is done in the port itself. The result after the proper calculation and conversion is displayed through a connected device. And second one is the real-time embedded systems. When an output is required at a particular time, real-time embedded systems can be used. When a task has to be completed on time or a deadline for a project, this system comes a savior. An external environment is controlled with the help of the computer systems. The third one is the network embedded systems. When a program is running inside another device, a network is formed. This is called the network embedded systems, where a microprocessor or a controller controls the running program. The fourth one is the mobile embedded systems. All the devices that are portable and working. These are the basic components present in an embedded system. One is the input device interfacing and driver circuit, and output device interfacing and driver circuits. Power supply, reset, and oscillator circuits. System application specific circuits, and timers, interrupt controllers, parallel and serial ports, program memory, and data memory. And main thing is the processor. In the next slide, I would tell about the microprocessor. Microprocessor is a programmable device. In embedded system, microprocessor takes the responses from the sensors in digital form and performs some arithmetical and logical operations over it and produces the desired output. In simple words, a microprocessor is a digital device on a chip that can fetch the instructions from memory, decode and execute them, and give the results. A microprocessor takes a bunch of instructions in machine language and execute them, telling the processor what it has to do. Microprocessor performs three basic things while executing the instruction. It performs some basic operations like addition, subtraction, multiplication, division, logical and or XOR, using its arithmetical and logic unit. Second one is the data in the microprocessor can be moved from one location to another location. It has a program counter register that stores the address of the next instruction based on the value of the PC. Microprocessor jumps from one location to another location and takes the decisions. The speed of the microprocessor is very high. Microprocessor consists of the various units such as control unit, execution unit, memory unit, and the registers and system buses for the data transmission. In the next slide, I would explain about the microcontroller. A microcontroller is a small computer on a single integrated circuit that is designed to control the specific task within the electronic system. It combines the functions of a central processing unit, memory, and I/O interfaces all on a single chip. Microcontrollers are widely used in embedded systems such as home appliances, automotive systems, medical devices, and industrial control systems. They are also used in consumer electronic products such as gaming systems, digital cameras, and audio players. A microcontroller consists of a processor core, volatile and non-volatile memory, input-output peripherals, and various communication interfaces. The processor core is responsible for executing the instructions and controlling the other components of the microcontroller. The memory is used to store the data and program code, while the input or output peripherals are used to interact with the external environment. Microcontrollers are programmable, which means that they can be customized to perform the specific tasks. The programming languages used to write the code for microcontroller vary depending upon the manufacturer and the type of the microcontroller. A microcontroller is self-contained desktop that can be utilized in an embedded system. PIC microcontroller is used in this project. PIC microcontroller is the RISC processor. It has separate code and data memory spaces. It has flash program memory, SRAM, and EEPROM data memory. It is a 40-pin DPIC and it has 15 interrupts. In this architecture, we have seen the different peripherals of the PIC processor connected to it. They are the general purpose IOs, I2C, and temperature sensors, and ADC and RS-232 ports, LEDs and buzzers, and digital keypads, matrix keypad. Next one is CLCD. CLCD stands for Character Liquid Crystal Display. There are two types of display, 16:2 display and 16:4 display. It is an electronic device which is frequently used in many applications for displaying the information in a text or image format. It displays the ASCII character and some special characters. There are two types of communication modes. There are the 4-bit mode and the 8-bit mode. The LCD is used for displaying the alphanumeric characters. The LCD display consists of the 8-bit data lines, that is D0 to D7, and 3 control lines, RS, read or write, and enable. Next one is the tactile switch. A tactile switch is one type of widely used switch that completes an electrical circuit typically when the pressure is applied to the device by the user, which then gives the user a perceptible click in response, indicating the current flow. Current flow is turned up when the switch is released. This switch is used to select the mode of the operation and to enter the temperature and time in our project. These switches produce the bouncing effect when one is the matrix keypad. A matrix keypad is the kind of keypad we see on the micro ovens, gas pumps, and the calculators. There are the different parts in the matrix keypad: 4x4 matrix keypad membrane, resistor of 1 kilo ohm, and jumper wires. This 4x4 matrix keypad has 16 built-in push-button contacts connected to the row and column lines. A microcontroller can scan these lines for a button pressure sheet. In the keypad library, the propeller sets all the column lines to input and all the row lines to the input. Then it picks a row and sets it high. After that, it checks all the column lines one at a time. If the column connection stays low, the button on the row has not been pressed. If it goes high, the microcontroller knows which row and which column. We have seen the schematic in the circuit section. ISR stands for Interrupt Service Routine. An ISR is a software routine that hardware invokes in response to an interrupt. ISR examines an interrupt and determines how to handle it, executes the handling, and then returns a logical interrupt value. If no further handling is required, the ISR notifies the kernel with a timers are used to keep a record of time for different events occurring in the embedded systems. The timer is a simpler binary counter which is configured in a circuit or a system as per the need to count the pulses in the system. The value of the timer is automatically set to 0 once it is at its maximum value. It has many applications such as measuring the time and generating the delay. Timer or counter is a software designed to count the time and timer intervals between the events. Most of timers are counter PWM and pulse.
Hello everyone, my name is Vinay Katta and I am pursuing BTech final year in the stream of Electronics and Communication Engineering at SRK College, Bhimavaram. Today I am working as an intern of embedded systems at Emertxe and I have done the project of microwave oven simulation in this internship. We did this as a group of 3 members and my fellow group members already presented the project. So now I am going to present the demo of the project. Now let's see code for the microwave oven. We have different modes in microwave oven. They are grill mode, micro mode, grill mode, and convection mode and start mode. We use a global variable which is a operation flag which is used in the code to select a certain mode in this. At first the operation flag is on the power on screen. While we switch on the microwave oven, we have to display something that we notice that the device is on. So we use a function called power on screen to display power on and microwave oven. And after this we have to print the different modes of the microwave oven. So for that we use a menu display screen to print the different modes of microwave oven like micro, grill and convection start. We have to select the mode which we want to use by from the keypad in itself. So by selecting the mode we have to clear the screen for displaying the timer. So we use a function called clear screen. Set time function is used to when we set the time for micro mode and grill mode. We have to set the time, and also for convection mode also we have to set the time. So we use this function to setting the time, and different options are available in while setting the time to clear or to enter the timer. So we have this like this, and blinking is nothing but we have to blink the number while counting from the number we given to 0. And also we have also time display screen which displays the timer to reducing by 1 second, which is given by us. After completing the timer, we have to get a notification that is time up, or and also we get a buzzer. We use a buzzer to notify us that the heating process is complete. So let's build this code. The building is successful and an X file has been created. Now we have to go to Pixsim lab to see the simulation. Go to file and load the hex file, which is already. Now let's see the output. While we on the machine, while we on the microwave oven, we can see like this display powering on the microwave oven, and we have different modes: micro, grill, convection, start, and we have to select the mode which we wanted. So I am selecting now micro. So which displays the first it displays 900 watts, and then we got, and that which is means in this mode we use 900 watts power, and we have to set that time now. So I am setting time for, and we can clear by pressing star symbol. We can clear the time like this. You can see in the, we can also set the timer for minutes also, and we after setting the time we have to press the enter. we have when we press we the timer is counting and we can see the fan is rotating. We can stop this by pressing pause button, which is 5, and we can resume this by using 4, and we can increase the timer by pressing 4 by another time. We can see that timer increases by 30 seconds, and whenever we want we can stop this timer by pressing 6, and we get the options again. The second mode is grill mode, which is also same as micro mode, but we here the power usage is less than a micro mode, and whenever we presses the button 2, we start the grill mode, and we have to start the timer, set the timer uh, by using the keys. Like this we have to set the timer, and we whenever we want, and we can clear this by using pressing the start, and after setting the time we have to press the hash to start the timer, and we can see the timer has been reducing by 1 second, and we want to pause it, we can pause by pressing 5, and we can resume it by pressing 4, and we can increase the timer by 30 seconds by pressing the 4 again, like this, and we can stop the timer by pressing 6, and we get out of the mode, this mode. Uh, like this, and the next mode is a convention mode. We have to press 3 for this. In this convention mode we have to set the temperature before entering into the heating operation timer. After entering the temperature, it has to be preheating. That for normally it is 180 up to 180 seconds. For simulation purpose we reduce it to the for 10 seconds. After this timer we have to set again, have to again set the time, like this. Now we have to set the time for heating the food we want to cook. Now I can press enter. Here also we can start or pause the, and we can stop the operation by pressing the respective keys. We can also increment this. Like this we got a message time up, and the buzzer also warns us that the cooking of the food is completed. And the last mode is start mode. It is we here we did not set the timer or anything. It is predefined to 30 seconds. This is used to cook for small items like that. We have to, whenever we want to heat some food items that are already cooked, so we use this mode for small elements to cook. And here also we can increase the timer by pressing 4, like this, 48 seconds. Now the timer is 46 seconds, or we can pause this. So like this we can, and we can stop this also. So like this in microwave oven we have 4 modes that works on the timer differently. So this is the simulation of the microwave oven we have done in this. So thank you for